Welcome. Today's lesson is how to monitor soil fertility in school gardens. It's kind of tough to manage not only your curriculum, but also manage the curriculum and a garden, whether it be a vegetable garden, a flower garden, or what kind of garden it is. It's kind of difficult to do that. And so I always try to find ways in which I can include students in the process. And I've used to actually have kits, have our kids actually collect the soil samples and then send them off to a lab. And that was all well and good. They would learn how to read the reports, and that was good. But the thing is, I really wanted them to actually take the samples themselves, and they did, but also do the testing themselves. And so I was on this search for what kind of kits I could come up with that were inexpensive, yet very accurate. And I found one. After several testings and everything else, the price as well as the amount of tests I could do in a particular year really matched up really well. And this is the one that we're settling on. And this is the LaMott, and it's the Garden Kit. And the numbers are right up there. I'll put it down in the description if we need to as well. So, and it has everything you basically need. You've got all the reagents that you possibly, and they're clearly labeled. And I think the amount of tests that I can do on this is pretty good too for the money. It also has some eyedroppers. It's got some test tubes, some plastic test tubes. So it has everything we need to be able to cook with. But it has some other amenities that I think are really important. These instructions are absolutely impeccable. It's really good graphics. It's easy to read. It shows you what you need to do, and you just follow it step by step. It's easy to do, and that's one of the reasons I got this kit. And it also has other things to make it a little bit more accurate. And I know the color charts sometimes, I know I kind of frustrated with them sometimes because it's really difficult sometimes to get accuracy. But these work pretty well, and our students have been pretty good at being able to use them. And then there's other things that come along with it, but for the most part, it has all the stuff. So the reason I'm buying this is, number one, is price. Number two, its ability to be able to engage our students. And then number three, it's accuracy. So those are the things I really wanted to focus in on when I was looking for a kit. And this particular kit, the LaMott kit, has it, the Garden Kit one. Okay, we typically will do this anywhere between 3 and 4 times a year because we produce about a ton of per year. So I want to make sure that we can keep on top of the fertility portion of our garden. And of course, they'll be a part of it. I make it part of my lesson plan when we talk about fertility in soils. So because I teach soil chemistry, so I wanted them to understand how we're monitoring nitrogen, potassium, and also phosphorus, NPK. Those are the things we test. So you might want to ask yourself, why did you want to test it to start with anyway? There's several reasons that it's important. First, when we're looking at all this, we're trying to get what the optimum value can be to get the optimum type of production with the right kinds of fertilizers and cover crops and all the other things that we do. We also want to be able to protect our environment from runoff and possibly any kind of toxins that might come from excess fertilizer use. And then we want to be able to diagnose any kind of problems that kind of crop up, excuse the pun, but anything that crops up in terms of plant culture. And then also we want to make the nutrients as available as we possibly can. That's why this kit is so important, and that's why we do it so often. It's relatively inexpensive, and it helps us to understand the chemistry behind fertility. And then the other thing is really what are we going to be testing for? N, P, and K. That's really the bottom line. When we look at nitrogen, we're looking at primarily any kind of vegetative growth. Potassium, we're looking for fruit and flower production and development. And then lastly, we're looking at potassium for its proper growth as well in reproduction, as well as managing the amount of water in their environment. So those are the reasons we continue to test. Now today what I want to do is I'm going to put it in a chat down below, or I'll also have it on a website that's also going to be listed. So really what we're going to be doing here is I've taken a sample And you can take a look at that sample. Now understand that when we took this sample, it was raining and it was wet, so we had to bake this soil. And once we did, it burned off most of the organic matter, and then I put it in the mortar and pestle and ground it up a little bit, so it's a little bit more consistency in its texture and size. So that's, and I got it out of the garden that I call the row crops. Those are the ones in the permanent beds, and those we've had carrots in there, we've had lettuce, lots of lettuce, we've had cauliflower, terrific cauliflower this year, as well as broccoli. So we kind of have all of that together, and that's where I'm taking it today. So we're going to go ahead and take the first test that it says in the book. And in the book here, it says here, we're going to do pH. Now, I normally have students take it with a pH meter, but since we got the kit open, we might as well go ahead and do that. When we're testing phosphorus during this time of the year, primarily when it's cold and the soil is cold, it doesn't really move that much. It's not very mobile. In other words, it's not going to go up into plants much. So at this particular time of the year, we really don't need phosphorus too much. But in the spring is another situation. Primarily because when we're looking at phosphorus, we're looking at basically flower growth and fruit growth. But again, that's not really happening to that either. But it gives us at least a foretelling of what could happen if we don't get some phosphorus in the soil. So now it's all kind of mixed. And then we're going to go ahead and put it up against this. And it matches really well with low. Yeah, very low. That means it's less than 50 pounds per acre. Now, when we're looking at, like for instance, tree crops, we're talking about anywhere from 100 to 200 100 to 200 pounds per acre. So we're really pretty low at this time. So we're going to have to include that in our report to what we need to do to be able to continue with our orchard. So anyway, there we have it. So that's number one, phosphorus. So I'm going to go ahead and write it on my data collection. I have my students always write it down on this and where it is. Now they should know that it's going to be in the row crops area. And for phosphorus, we have 50 pounds per acre. And so that when we fertilize next, guess what's going to be in the mix? Phosphorus. So that's how this is what it looks like. I try to keep it really simple so students can follow it easily and have it on their computers all the time. We're going to be taking a look at our pH, and you notice it has a different kind of color. So here's a color card, and this is our pH. Anybody see? Don't look at the brown stuff on the bottom, look at the colored stuff at the top. So let's take it over to this camera. Which one do you think? Which one do you think? It looks like it's a little bit on the alkaline side, and it would be, yeah, this purple. So I'm going to go ahead and put on our data sheet pH equals 8. Now I'd probably look at it again with an electronic device just because I just want to make sure that it's correct. I'm not saying it isn't. I'm just saying that we have an alkali problem. Not too drastic. But we do need to, that's another thing. So we have two issues. We have, first of all, really low phosphorus, and then the other thing is we have kind of an 8, so it's a little on the alkali side. We're going to go back to our nitrogen test. I think it looks a little bit, it is kind of on trace, but I bet if I let it sit another minute or two, it's going to get probably on the low side. So we're going to go with low. And I'm going to go ahead and put it on our chart. Low on the chart is 30 pounds per acre, which isn't terrible, but it's not great. All right, here it is. Now, what this means to me as the teacher, and what I need to stress to students, is the fact that we've been using that space a lot this winter time. We've had 4 different crops in here. It's probably time not only a rest, but also add some cover crops to it to get that up, because we're going to need that space for, we have a corn, I want to have corn come in after this, or tomatoes. So they're going to need a lot more nitrogen than 30 pounds per acre. So one of the things that you can start doing with students is you start like forecasting and making predictions and making plans for what happens next. So this test allows us a lot of conversation, and they have to write the recommendation. I won't. They have to, the students, that is. So far, it's working out fairly well, but we have some work to do. Potassium test solution, that's what we're going to be doing next. It changed color at a blue, which means it's medium high. Medium high means that we have something close to about 150 to 100 pounds per acre. So we don't have a problem with potassium. It's in good shape. So when we go to our data collection, it's about 100 and, let's see here, what do we got here? Medium high, so it'll be 150 per acre. So we have a pH of 8, which is a little bit of a problem. It also has nitrogen. We just need to obviously kind of give our area a rest and put some cover crops in it, maybe something like fava bean, maybe beans, and then also obviously some fertilizer as well. And then we have 50 for phosphorus. I don't think that's going to be too much of an issue if we just continue fertilizing like we always have. That'll catch up with it in the spring. And then 150 pounds per acre of potassium. So we got to take care of the pH. We got to take care of the nitrogen, and I think we'll be all right for upcoming summer. So there you have it. That's how it works in the classroom, including make sure you include the students. Make sure that you're always going back to the, making sure you go back to the garden. That's your anchor point as far as teaching your students how to manage the fertility of soil. And at least my students get kind of involved in it, and they love to track what's going on, because sometimes if that's their area that we've assigned them to kind of to manage, they really do get worked up about it. So I hope that this has helped you. I hope that you'll have the same success or better than I've had using this particular kit. So next time, thank you. We'll see you in the garden. Thanks. Bye.